what is the point of doing these problems? Why involving calculus at all? Like, why do we have to take the derivative? Again, these are really good questions. Like, what the heck are we doing? So let me draw. Is it number 6 that has the rectangle under the triangle?
Yeah.
Okay. Was that a sad yeah? This is kind of a fun one. There's a lot of just good stuff in here, so I'll draw it out and we'll talk about it. Let's see. This is boom. Oh my gosh. Okay, so we got this rectangle that's, we want to maximize the area. I'm going to do this one. Is this all right? I don't know what the problem was. Is this 5?
Yeah.
Just to kind of get the general idea for everyone, I'm going to talk about together, how would you even approach this problem, okay? Well, again, so we want to maximize area of something. It's a rectangle, so what's the first thing we're thinking? Yeah, area of a rectangle equals length times width. Okay, so what is the length of this rectangle going to be? Yeah, you're gonna it could. We start the x at 0, and see what we're doing, you guys. Can you guys picture me sliding this thing? You know, I start here, the x, take the slide, and I'm sliding it back and forth. When I do that, it shoots up to the graph, and it starts out really tall and skinny. And then it gets kind of, you know, as I start here, just scoot it over, it's this real skinny one. And then it's like some boxy looking thing. And as I go all the way down, we're creating these different rectangles as you slide from left to right, from the 0 to the 1. Does that make sense, you guys? As we're changing the x value, we're changing the area in the rectangle. Do you guys see that? So A is increasing. A is decreasing. Well, these are calculus terms. We know when to find when something is increasing and decreasing, and minimum and maximum. All of that has to do with the derivative. So if we can somehow get some equation for the derivative, A equals something, and if it's in terms of one variable, great. Well then with that, what you can do is take the derivative. Why? Because what you can do is set up a sign chart. And you can see when is the area increasing, when is the area decreasing. And with that you can find, when we set the derivative equal to 0, to find when that rate of change maxes out. Does that make sense as the goal of why we're even doing this, you guys? Does it or no? I mean, it's such a good question. Why we take the derivative, right? We're in a calculus class. Take the derivative. All right. Set it equal to 0. Why we've done that? The goal of this problem is why we set it equal to 0, why we take the derivative and set it equal to 0, is we want to find those minimum and maximum points. And we can do that by taking the derivative and setting it equal to 0. How are we feeling, guys? Yeah? Alright, so this length is 2x. Now how do I figure out the width? Well, the width is the y value. How do I calculate that y value? What do I do? I don't have an equation, Amina. No. Come on. Sonia. Okay. Okay, I don't know. So it says isosceles. What does that tell us? My question would be is that can we figure out the equation? We don't have one yet, but that's what we need. We need that y equals equation. If we have that, if we get the equation, then we can get cooking. I just don't know what it is. I mean, but okay, isosceles triangle. So, yes. Okay. Or going this way. I'm just going to look at this little guy too. See that one? Okay, if this whole thing is an isosceles right triangle, then this is 45, this is 45, and this is a 90. Does that make sense? then if I break that down into this thing, this is a 45, that's a 90, then this one has to be what? This is also an isosceles right triangle. What do I know about 45, 45, 90 triangles? Yeah. S root 2. I know the side lengths. So since this side length is 1, this is going to be 1, 1, radical 2. Okay? Well, with this length, I have this point. With 2 points, can I figure out an equation of a line? Yes. How do I do that? I'm talking point slow. Yeah. Okay, so let's do it. Like, what's the equation of the line? How do I do it? 2 points. How do we find the equation of the line? If you want to do y equals mx plus b, fine. I have the b. B is 1. How do I figure out m? Change in y over change in x, which is what? This minus this, negative 1 over 1. Slope is negative 1. Y-intercept of 1. What's the equation of the line? Negative x plus 1. Great. This y equals negative x plus 1. With that, I have an area equation just in terms of one variable. And if I multiply it out, I have an area equation. Now what can I do with my area equation, Anna?
Find the derivative.
Okay, what am I going to do with the derivative?
Set it equal to 0.
d dx both sides. Do these numbers look right? Okay. I set it equal to 0 and solve for x. What do I get? What does that mean? What did I just do? What is it, Roxana?
We found either a min or max.
Yeah. So how do I determine if it is a min or a max? Let's do it. Let's set up a little sign chart. Boop, boop. We'll check the derivative and we'll see what the function's happening there. Okay, so here's my derivative equation. A number to the left of 0.5 is, Sandy? 0. Does that make this positive or negative? Positive. A number to the left, to the right of 0.5, Sandy, is? Does that make this positive or negative? Negative. A derivative being positive and negative, what does that mean, Chris? If something is increasing and then decreasing, what is that telling me about 0.5? It's a max. You just solve by hand where this function maxes out, at 0.5. Now how could I go about figuring out what the area is at this point? Okay, okay, what do I get? 2 times 0.5, so 2 times 1/2 is 1, is, okay, so this equals 1 times negative 0.5.